everyone, Brad from REV. First Global and REV Robotics are excited to reveal the first ever REV Duo FGC starter bot for the 2026 First Global Challenge, Igniting Innovation. This robot was created to help teams around the world get started quickly. We share the CAD, build guide, and documentation so teams can see how it works, learn from the design, and start building their own solutions. The starter bot is not meant to be a final answer. Think of it as a spark. Use it to light new ideas, test improvements, and build momentum for your country's robot. We'll follow this with a full walkthrough video, and you can find the technical documentation at docs.revrobotics.com. Questions? Leave a comment below or email support@revrobotics.com. Good luck this year. Now go ignite your innovation and let your ideas catch fire. Hey, this is Brad with REV, and I'm joined by Craig from REV's mechanical engineering team.
I'm excited to talk about our 2026 Duo FGC Starterbot First Global Challenge, Igniting Innovation.
This year's First Global Challenge brings teams from around the world to Incheon, Republic of Korea, where they use creativity, engineering, and problem solving to help explore how technology can help reduce the risk and impact of wildfires. Craig led the design of this year's starter bot, so he's the perfect person to walk us through the robot, explain the mechanisms, and show how teams around the world can use this design as a strong starting point for the First Global Challenge. All right, Craig, so let's start with the base of the robot, the drivetrain. This looks similar to our channel drivetrain. Was there anything that you modified or changed here?
Yes, so the rear motors and rear wheels have been moved back a single hole, and that was to make some space at the front of the robot to have a hopper that was large enough to hold enough balls to do plenty of scoring. That meant that we bought some space for our launcher system at the back here.
Gotcha, okay. So let's move on to the front of the robot here, and I guess interacting with the game piece, the Wildfire. Can you talk us a little bit about the intake?
So the intake is driven by a HD hex motor with a gear ratio. You need to kind of pick your own gear ratio. Faster is better, but you also want enough power to be able to pull it back in. So we've done several different versions. You can fit any up to 3-stage ultraplanetary in there, should you wish. We're currently using a 12-to-1, I think, and that is driven through a 90-degree gearbox, which pulls the game pieces in from on the underneath. The flat wheels do all of the actual work as they pull it in, and the big compliant wheels at the side keep the game piece from hitting the frame and getting jammed against the frame.
So just talking about like gameplay variables here, this robot is able to kind of control Wildfire in other ways of just being able to move it, right?
Correct, yeah. So the front of the robot is a nice big flat area. So for if any reason at all your intake isn't working or it stops, you can just take the Wildfire pieces and push them around where they need to go. If it does work, currently we have it so that you can extake and then you can reverse your intake and you can push the game pieces, the Wildfire, into the fire shield. So the human player can then score from there.
So the intake is actually pretty wide. Can you take in 2 Wildfire at once?
You can. You'll need a higher ratio to pull in more game pieces at once, but it will pull in probably 2 or 3 at a time. 3 would be a bit of a squeeze, 2 for definite. The whole hopper itself will hold about 8 to 12 game pieces. That kind of depends on how you drive. 8 will stay in. 12, there'll be a kind of a bit of a pile on top, and as you drive and turn, things will fall out.
Okay, so mentioning the hopper, and you have this superstructure of aluminum. Can you kind of talk us about the structure of it, how it's built, and anything that you might do in the future?
It's as big as we can possibly make it without interfering with the other systems that we need. So the coroplasts on the sides are basically to stop the game pieces from falling out, because without them, they will fall out. You don't have to use the coroplast. You can use polycarbonate if you want, but this is super easy to cut, and it meant I could do it in like 5 minutes, so I did it in coroplast. But anything will work. The idea of the hopper itself is to make sure that you're holding as much as you possibly can, and nothing is falling out where you don't want it to fall out as you're driving around.
All right, so now as the Wildfire is in the hopper and we have them driving around, we then kind of come into the need to launch them. But before we get to the actual launcher, what do we have here that is effectively, I guess, feeding it in?
So we have this core hex motor here that is moving these 4 flat wheels here. They have been kind of contoured so that they don't interfere with the launcher motor. And what they do is it just slowly rotates and just forces the Wildfire game pieces into the launcher. So there's plenty of other ways to do it. This was the simplest way of doing it.
So now as we have this feeder system that can now bring in the Wildfire on demand, it has to go to something to launch it. And so we have this launcher system here. And I see that we have a new product that we've not seen in First Global kits, which are these cone wheels. It looks like there's 2 motors, there's an extra wheel, there's chain. Can you walk me through what's going on with this launcher system and how it kind of functions?
Okay, so we'll start with the wheels in the center. So the cone wheels centralize the game piece, the Wildfire, into the center channel of the launcher so that we get a nice clean shoot all the way through. And the cone wheels, being slightly bigger than the middle wheels, help you keep in contact with the game piece all the way through the launching system. So we have 2 motors. We have the first motor here, which is spinning the direct shaft that the cone wheels and the compliant wheels are on. And we have the secondary motor, which is spinning a flywheel, which helps keep the launcher system spinning. And that is connected by chain to the back of the motor over here. So the idea of the second motor is just to keep the launcher spinning while we're trying to shoot through. So as the ball hits the launcher system, there's a power drop. So we want to keep the extra motor, helps keep the first motor spinning so that we get a clean launch and we get lots of clean launches rather than just shooting once and then once and then once. We can actually shoot repeatedly.
Gotcha. And so both these motors are effectively 1-to-1 and they're hooked up together to basically keep this launcher going shot after shot.
Correct. They are absolutely connected together by this chain, and they are connected together in the electronic system, which they all tie into the control hub.
Gotcha. And it's a really clever use of effectively wheels to add this extra weight for that flywheel to keep it spinning and keep that momentum. I really like that's kind of a clever use of that, and I like seeing teams use parts in ways maybe they weren't intended for, but that they end up being a great use for. So as we have our launcher, I guess another important thing to consider is kind of the back wall, sometimes referred to as like the chute. How important is this? I see we have no actual hood here. What could teams do here to maybe improve or to tune in shooting or launching?
So as you remember from when we were doing our testing, the Wildfire pieces were going directly up at one point, and then by adjusting some of the bracketry and the angles and removing bits and pieces here and there, we actually could change the entire trajectory of the shot. So we could either shoot really narrow, so we could be bumped up really close to the goal, or we could move it down as we have done with this version so that we can shoot from a little bit further out. So by adjusting how these are mounted, all of it, you can change how the shot comes out of the ramp, out of the hood, into the goal. So you can kind of tune your own shooting system.
So I guess if teams want to focus on something to really test and tune in, effectively the chute or the back end of the launcher is really the best place to spend some time and make sure that that shot trajectory or that launch trajectory is kind of where you want it, right?
Absolutely, yeah. So this is kind of as good as it needs to be right now. And this is a real big area of improvement that people can take a look at, see what we've done, and improve upon. So I don't want to see anybody using the standard one. I want to see everybody innovating and doing something new with this.
And so I guess a big component of this is the actual geometry and the structure here. And we'll get into the programming video to get more into some details here. But keeping and maintaining this velocity or the speed is very critical to having a consistent shot, correct?
Absolutely, yes. And the other thing that you're going to need to do is to make sure that all of these bolts in this bracketry back here stay nice and tight, because they will loosen, not after every match, but fairly regularly. So one of your maintenance things that you'll want to do is to be making sure all of these are nice and tight, and that we're held at the bottom, we're held at the top, we're held everywhere. So it should be one of the first things that you're checking, because if you're not scoring whereas you were, that's probably why.
All right, so getting into the end game, we have this really interesting challenge with the brace, this long pole that it looks like you have to kind of hook on and get up, and you have to drive all the way up as high as you can and try and get all your teammates to do the same thing. I obviously can see what's going on for that, but can you tell us about, I guess, the design of this, how it works, and kind of where you got to here, or how you got to here?
So the intention is that you'll drive into the brace kind of in this kind of orientation, and then you'll kind of turn while driving the cone wheels on the top, and that should take you a little bit of a tiny little bit of wiggling backwards and forwards to find your balance point. And then as you drive up the brace, it will actually rest up against this upright here, and you should be good to go all the way up to level 3. The intention is to go launcher first, so that the actual weight of the robot, because this is actually front of the center of gravity, so that we're bracing correctly in the right direction as we climb up the pole. It will do it in 28 seconds if you can get it right. So I promise you, we'll do it.
So a really key aspect, I guess, of this challenge is the balance of the robot, where your point is that you're hanging from, if that's your direction, and if you're doing it that way, making sure that the weight is right, and maybe testing that, and putting on the pole and trying to find where can it balance and be able to drive at the same time.
Correct. The other thing that we've done with the climber is that we have used the harder compound wheels on the top. So these are the black colored ones instead of the gray colored ones that are in the launcher. These will last longer, so you have the whole weight of the robot on these two wheels. After 2 or 3 matches, the lighter colored ones will deform. They'll still work, but you'll need to replace them.
Well, thank you so much, Craig, for walking us through the 2026 FGC starter bot build and kind of your design intentions and where you came at. Do you have anything else to say?
Yeah, I think this is a great starting point for a lot of teams, but I really, really want to see what you guys come up with and see the innovation that you guys can create with the kit and any improvements that you make. Take pictures and tag us in them.
If you're just as excited about the 2026 REV DUO FGC Starter Bot and the First Global Challenge igniting innovation as we are, you can find more information about REV products and resources at revrobotics.com. For the full CAD, build guides, code overviews, and additional starter bot resources, head over to our documentation at docs.revrobotics.com. And to learn more about First Global, this year's challenge, and resources available for igniting innovation, check out first.global/FGC. Feel free to leave a comment on this video or reach out to our support team at support@revrobotics.com. Good luck, and we can't wait to see what ideas teams from around the world bring to life. Now go on and ignite some innovation.